Live now from downtown Mill Bay. Also, device policy. I haven't, Ms. Stevens, last year, I always quite admired. She would like collect everybody's cell phones and put it in a box. And I've never done that. And I asked my class, like, should I do that? And they were all like, no, you should never do that. So I'm still doing what I normally do, which is if I see your phone out, I'm going to ask for it. And then I'm going to keep it for the rest of the class, or any device that you're misusing that's posing a distraction. If you're on your computer taking notes, but you're flipping and watching a game or something else, then it just becomes mine. If it happens more than a couple of times, then I just give it to your house parent, and then they apply whatever policies they need to. You were observing. These are your observations. I'm no comment. But you can ask those around you. There's multiple observers. I don't want to interfere with the observing process.
Oh, it wasn't headed out.
Yep, observations right there in the front if you have not yet already. Today's lesson, Science 10. Let's go. Go Gadget Machine. My school. I haven't done attendance yet. That's right. What? Sorry, it's not taking attendance for me right now. Yes, question.
On that thing up there, on all of them, it says what it is, except for the brain, it just says head. So we have lungs, heart, liver, kidneys, and then head instead of brain.
I will go over that in a moment. That's because occasionally I teach biology 12. Why can't I? Oh, finally. My school kicked me out 3 times. It didn't want me to take attendance, but it seems to have fixed itself. And my schedule. And we're near the end, but we did a lot. We had a whole quiz, we had a demo, and now we're going to race through some notes. Timmy? Ben?
Yep.
Jonathan?
Yep.
Ariel? Zoe?
Yep.
Lisa?
Yep.
Felix?
Here.
Zane?
Yep.
Matthew?
Here.
William?
Yeah.
Alejandra?
Yeah.
Bertie?
Yep.
Zachary?
Here.
Kieran? William?
Here.
Naomi? Hugo?
Here.
Sahir?
Here.
Nice, we're all here. Okay. So, let's open up this one. You asked about this and why there's just a head. This is for a project in Biology 12 in which you have to show how certain organ systems are connected via their blood pathways. So it used to be also labeled and the strings meant something, but the labels have long still fell off. But since they like painted it, and like I have no talent at painting, so I thought that's like cool and art, and I put it up. Yeah, just like that one, it was a 3-dimensional representation of the heart. They had it completely labeled with all the different spots. All the spots and the things on top of it fell off, and now it's just a crocheted heart. It just sits on the wall. And there was writing on my whiteboard. And there we go. We were down to here, and now we're going to get into the Bohr model, which should be a review of last year. The Bohr model is, as you know, completely incorrect, but it's really useful, like most models, because there is an area where it's true, and that is in predicting chemical reactions. There's a lot of chemical reactions you can predict with it, and so we still teach it because it's a nice, simple model that works for like 90% of what you're going to do right now. In Chemistry 11, you'll get exposed to quantum chemistry. And then after we teach it to you, we will go back to very carefully pretending that quantum chemistry doesn't exist, because the amount of calculations you're required to use it, you really only need to do in special circumstances, and Bohr still works. The process of science is making models. Science never actually completely says anything's 100% true, just that the model works under certain conditions. Yeah. I did. It used to be up at the front. Check the desk in the back, and if it's not, just fold over the pages. And make sure your name is on both, and that should be good. If it's not on the desk, I don't think there's one there. Someone has stolen my stapler. Oh, wow. Okay. We've got chemical properties. Let's just finish that off. It depends on the most important subatomic particle. Which is the most important subatomic particles? No, that's the atom. The subatom, subatomic. Protons. That's what determines everything else. And protons determine the number of electrons, which in turn determine the chemistry. So everything depends on the number of protons, what it is. So it depends on the number of protons. And then the number of electrons, because those follow. Although those can change and make an ion. And what are these? When you have like a little atom, you would make your atom and you'd make little circles around it and you'd go like this. What were these things called? The valence shell. Ooh, the outer one is the valence shell. We're going to label that one. That's really good. What were they called in general? Pardon? Well, that's the valence shell. That's the outer. There's this one here. It's not the outermost shell. That could be the innermost shell. I like how you're doing it. So they are called shells. So they're called electron. That says electron shells. They're also known as energy levels. And the entire point behind that little demo right there is if you have an atom and you have an electron and it's in an energy level, and then there's another energy level up here, if you apply fire to it, energy of any kind, you can get that electron to jump up. You give it energy, it's gone up. But anything that goes up must come down. So that it's unstable, it must go down. To go down, it has to lose energy. Now, if someone shoves you in the air and you come down, you're gaining kinetic energy. Electrons cannot gain kinetic energy in that kind of way. So they have to shed the energy in a different way. And they shed the energy by giving off light. Hence the different colors. Different electrons going up different levels will shed the energy coming down and give off different colors. So you can precisely identify what element something is by what colors it gives off. Now, some of the colors are not necessarily ones that you can see, but a lot of them are. We picked, of course, for that particular demo, some particularly colorful ones. But you can get very granular with that, with very exact ones. And that's how we know what our sun, for example, is composed of. We just look at the colors that are coming off, and those must be the elements in there. And the composition of other stars. No one's gone to the sun and taken a sample. We're just inferring based on color. So I would like you to draw the Bohr model for lithium using your periodic table that you would have drawn last year right here. Then we're going to draw maybe a simpler one on the right that I'd like you to get used to here. So Bohr model, lithium there.
Do you want the electron levels and all that?
I want the Bohr model for lithium you would have drawn last year.
Oh.
So all the things that you would have drawn last year. And there's flowers in your textbook? I feel like that should stay there forever and just be a gift for every person who takes it. Yeah. Oh, I'm not saying anybody's way of drawing it is wrong. I just want an example. In fact, now that I think about it, once you've drawn your example, I'm going to do the better Bohr. And it's not better, it's just sometimes more convenient. Better is not the best way of putting it. However, given I don't know where everybody came from and what schools you were before, go find your people. So get in groups of 3. There's whiteboard pens over there. I want you to find a spot on the board, and between your 3 models, put up the best model you can on the board. I want to just take a look at what everybody's got. Find your people. You want to hand it in and prep?
Because I'm gonna do a lot more live. I literally wrote down quick notes when we were doing it.
Yeah, okay. Ask that question once everybody sits down, because I'll also tell people how to hand things in after class. Ask me that again once everybody sits down, because I'll also tell people how to hand things in after class. Find your people. Draw it on the board. There are whiteboard pens if you need them. Right over here. Draw the best version. Where's William K? There you go. Now, reminder, in this type of learning environment in which someone is drawing and the other 2 are giving advice, if I come and ask you questions, the person who draws cannot answer them. It must be the people who are beside. Zach, where's your group? Be with your group. You can do that after you. Converse with your group. Your number of nights you do. I want you to use the best board model for plain. If you give a another type of look, make sure you label it correctly. And make sure you have the right number of protons and neutrons. Your neutrons might need work. Ooh, like that? Nice plain old lithium. Good. Excellent. Excellent. Oh, the dash method. I've seen that. And capital E. Well, why are you erasing first? But did you ask permission first?
It's 6 point.
Okay, you kind of took over.
I know. I asked questions.
Wait. Is it the 3rd? Okay. It's subverted. Nice. We've kind of gone about periodic tables, so it's kind of
I handed you all a period table, didn't I?
No.
What?
That might be.
There should be one in the back of your book, but I swear I gave you guys a period table. No? Vicious lies. Vicious. Okay, next day I'll make sure you get your periodic table. It's probably sitting on the photocopier somewhere. There, hold it. Textbook. There is a periodic table in the back of your textbook. I knew there was one you would have access to. So double check with the textbook if you need it. Okay, you get your stuff. We have a differing amount of protons. How many protons should it be? Should be 3. How many neutrons should it be? 4. Should be 4. Now, if you put down 3, that's probably a stable isotope. You're not too far out, but it is not a likely isotope. How do we know it's not a likely isotope? You might need a periodic table for that. Yeah.
Because like I forgot what it was called, but it's like the decimal number.
Yeah, the decimal number. The decimal number gives the average mass. So on average, lithium weighs about 7, which means it must have 4 neutrons, 7 minus 3. Now, it's a decimal because it's an average. If I said, and this is a true number, there are 1.6 children for every family that has children in Canada. You're not walking around looking for a 1/6 of a child in every family. Even if you get your arms and legs cut off, you're still a whole person. Still 2 children. It just means if you calculate the average, you get something that's in between. Averages aren't real necessarily. So, same with atoms, they have to have a whole number of neutrons. We estimate that to be about 4, given that it's about 7. Okay, have a seat. I will, now, all of those, the slash method is, oh, you just erased yours. I liked it.
Not mine?
Daniel, how could you forget your notes already?
Because I don't
Yeah. So I'll just pick one of these. I'm looking over there. It would actually be 3. They reverse those. Draw a circle around it. And then we have 2. And then we have 1. Because the number of electrons should match the number of protons. So that's, now, the reason why I say a better model is if you're drawing a lot of board diagrams, this is all empty space that you're just drawing just to show a circle. And by now, you should kind of know it's a circle. And by next year, we're going to tell you it's not a circle anyway. So what's the point? So if you're drawing it, it would be 3 protons. And you include a little plus sign to show, because there's actually other things that have a P in them, like phosphorus. So we put the plus to show it's a proton. 4 neutrons. What's the charge on a neutron as a reminder? A little 0. Do that. Now, if you want, you can put a little circle around it. You don't have to. I often do just because I do. But if you just go 3 protons, 4 neutrons, that's fine. And then you just, very similar to that one over there, you just go 2 electrons, 1 electron. And if you like to show that there's circles, you can put little dashes on top. Those are meant to represent this entire thing you used to make. Now, nobody made the one I was expecting, which is why I'm glad everybody put it up there. Because the one I was expecting, don't go just yet, was where people, has anybody done these ones? Where you put dots around those? You have those? Those are very similar to Lewis dot diagrams. We will do those, but don't do them unless you're doing a Lewis diagram. It makes them hard to count. Now, as a warning, next day will be a lot more notes because we're going to get further in the material. I'm not going to have a demo. So come prepared to pay attention and just go, go, go. No quiz next day. Oh, how do you hand in things after class? No, that's a terrible way. I lose things in my office. No. Have you not? How many of you have heard of reception? Every teacher has a mailbox there. You put your name on it, you put my name on it, you take it to reception, you say, please put this in Mr. Neuveld's mailbox. It stays in there, and then I put it in the right spot, and I don't lose it. If you're in the house, you can still give it to me, but for most people, reception.
Oh, thank you. Okay.
And do not slide it under my door. Those get trampled and thrown in the garbage. It has happened where someone slid something under my door. I never saw it, and it just disappeared. Yeah, yeah, and then put it in the office. Yeah, those are fine. Yeah. Woo-wee. Two questions. First question.
Comes with little
One second. I should stop this.